1/4 times the ln of u, absolute value of u, plus c, of course. So in the end, you have 1/4 ln of your u, which was x to the 4th minus 5 plus c.
Oh, great! Now, we'd like to learn something different, so we're going to go to Miss Hawkins.
Hi, class. Now I'm going to be teaching you about absolute maximums and minimums. Now we have our local maximum and minimums, which would be just right here and right here. But what we want to find is the overall total of the whole function, the maximum and minimum, which would be down here and up here. Now how you do that is you're first going to find the first derivative, which we all learned from Miss Bowles. Then you are going to set that derivative equal to 0, and you are going to find the values of x, which is also known as finding the critical points. Then you are going to find your critical points and the endpoints that you will be given in your problem, and the most important thing is you plug that back into the original equation. So here is our first example. We have 3x to the 4th minus 4x cubed on the interval of -1 to 2. Now, what you're going to do is you're going to find the first derivative, which is your first step. So that is going to be 12x cubed minus 12x squared. In your second step, you're going to set that equal to 0, which you can just do up here to make it easier. And you're going to find your critical points, finding your x's. And an easy way to do that is, since you have a 12x squared in each one, you can just pull that out right away. So you do 12x squared, and what you're left with is an x right here, and you just replace this with a 1. So then you're going to set each of these individual to 0. So you're going to do that, and then you're going to do that. So, and once you solve those, just like you normally would, you're going to get x to equal 0 and x to equal 1.
I get it.
So then, our last step is plugging your x's and your endpoints into your original equation. So you're going to do, we'll start off with our original points. So you're going to do 3 times -1 to the 4th.
Someone have their phone in class. Get out. Detention.
Minus 4 to the negative. I'm sorry. It's just regular 1. Okay. So we're going to 3 times 1 to the 4th minus 4 times 1 cubed, which you are going to get 4 times 1, or 1 to the 4th power is just 1. And then 1 times 3 is 3. And then 1 to the cubed power.
1
times 4.
4.
So it's 3 minus 4.
-1.
Good. So your overall coordinate right there is going to be 1, -1. So then you're going to plug in your next critical point, which is 0. So you're going to plug that all in again, but just with 0 this time. And this is just going to equal 0 and 0 and then minus 0. So your coordinate is just going to be 0, 0. So now we're going to go to the endpoints. You're going to have 3 to the -1/4 minus 3 times the -1 cubed. Now what's -1 to the 4th?
1
Times 3.
3.
And -1 cubed?
-1.
Good. Times 3.
-3.
Okay, good. So what is 3 minus -3?
6. 6.
So it is going to be the coordinate of 1 to the 6th. So now we just have one more endpoint to do. So you're going to do 3, 2 to the 4th minus 3, 2 cubed. And once you do all that math, you're going to get to equal 16. So your final coordinate is going to be 2 to the 16th. So now you're going to look at all your coordinates that you have, and you're just going to imagine them all on a graph. and think which one's going to be the lowest point and which one's going to be the highest point. So we have, which one does have the lowest y value?
0, 0.
Or 1, negative 1. So your 1, negative 1 is going to be your minimum. Now which has the highest y value?
216.
Good. So 216 is going to be your maximum. Okay. Now we are, after all that work, we are going to go to Miss Reynolds, who is teaching us about radioactive decay and proportional rates.
Hi, I'm going to teach about radioactive decay and proportional rates. So the first equation that you're going to learn about would be y equals C1 e to the kt. And this is the equation you use to find out certain aspects of radioactive decay and proportional rates. But I will show you how this equation is derived. First, we use K and Y when dealing with radioactive decay. Y is just the amount of a substance. K is the amount the derivative is proportional to. So we're going to start with that phone. We're going to start with dy over dt equals K times y. But now we're going to find the antiderivative. So to find this, you would do this side, the antiderivative would be 1 over y dy equals K dt because of the y.
Did you just separate your variables there? Is that what happened?
I don't know. I think so. Yes, I did.
I think you moved the dt's to this side and the y's to this side. So then you would have 1 over y.
Look how smart she is.
Just wanting to contribute to the conversation a little bit.
Look, I just gave her a quiz and she got it right. Okay, so then after you do that, you need to now we need to find the antiderivative. So we're going to ln this side because 1 over y is ln of the absolute value y equals kt plus c. And we do the plus c because you always have to do that with antiderivatives. Well, then from there we have to get rid of the ln, so we're going to e both sides. So then after you e both sides, you have, let's do it up here, y equals e to the kt plus e to the c. Well then, this, if you make e to the c, you can make it c1. So then that gives us y equals c1 e to the kt. And that's the main equation that we use for radioactive decay and proportional rates. So now that I taught you how it's derived, which you won't really have to ever know that, maybe on the AP test that could be a question.
Oh, I'm really nervous for that.
Yeah. But for now, I'm just going to teach you examples of how to use it. So our first example is going to be called Pu-239, and it's radioactive decay. So it's a word problem, so it's just Pu-239 has a half-life of 24,360 years. If 10 grams were released in the accident, how long will it take for 10 grams to decay to 1 gram? So the first thing we do is t equals 0, and this makes the time for the beginning. T equals time. And then y is how many grams is at the beginning. So at time 0, there's 10 grams. Then we know that a half-life is 24,360 years. So that's our half-life. So what is half of 10?
5.
Good. So this is the next step. Well then, we want to find how long it will take to have 1 gram. So we take y equals 1 gram, and we're trying to find how much time that is. So in order to do this, we plug it into y equals c1 e to the kt. So we take this information, and the first one we're going to plug in is this part, the very first beginning part. So you have 10 equals c1, 10 because y, c1 e to the kt. We have e to the k. We don't know what either of those are, but we do know our t is 0. So we make it 0. Well, then we know that 0 times k, anything times 0 is 0. So e to the 0 is 1, and c1 times 1 is c1. So c1 equals 10. And now, for the rest of the problem, 10 is what we're going to be using for c1. So then after that, we already used this information. Now we're going to use this step to find k, because we still don't know what k is. So we're going to go, since y equals 5, 5 equals c1, 10, e to the k, and then our t is 24,360. Now we just have to solve for k. So we divide by 10 on both sides. Then this side equals 0.5, e to the k, 24,360. Well then, how do we get rid of our e's?
ln.
Good. So we ln 0.5, and that gets rid of our e, so we have k to the 24,360. Then, from this, we divide by 24,360. Then that gives us our k. And to make it faster, I'll tell you what the k is. It would be negative 2.84. So now we have our k. And since I don't have enough room, I'm going to erase this stuff. Good, so now we're going to do the very last step of the problem. So we had t equals 0, y equals 10, t equals 24,360, y equals 5, and now we have to find this last part. Correct?
Mm-hmm.
Okay, so we know we're going to use the beginning, the 10, I didn't mean that. Now we have to find what t equals, so we're going to use this very last step. So y equals 1, and we always use c1 equals 10, 10, e to the k. We know our k, and we plug that into our calculator, and you all know how. And then t, we don't know. So then, we divide by 10, because we're trying to solve for t. You get 0.1 equals e to the k t. Then we ln both sides. And we do know what k is, so we divide by k. And t equals, I'll tell you because it's faster, 80,922.16 years. Now that's how you do radioactive decay. But now we're going to go over to proportional rates. This is a long process, I know. But this one's a lot quicker. So, now we're going to do fruit flies. Okay, we're going to do fruit flies. So, we start out with 100 fruit flies. So you make that. It's about the same process. You make that 100, and then time equals what?
0.
Good. And then after 2 days, there are 300 fruit flies. So what has happened? What has happened, Emily?
Fruit flies made baby fruit flies.
Good job. So then we're going to ask how many flies will you have in 5 days? So I'm pretty sure I'll let you just do this one by yourself on your own time because I'm pretty sure you can. So this is how we do proportional rates and radioactive decay. Thank you.
We hope you enjoyed our presentation.
Okay.
Bye!
You have it upside down.